Okay, so I guess we are online now. Rashbir, hello. How are you?
Hello, Mika. I'm good, thank you. How are you?
Fine, fine. It was a long time since the last webinar.
Yeah, a really long time. I think we
You-
both were busy in some of
yeah,
the projects.
yeah, we've been very busy, but it's nice to be back. And today we will have like first webinar for this new period where we are gonna talk
Cool.
about what has gone, what we've been working in
Mhm.
Simumatik the last month. So I would say almost the last half year. A lot of things have
Okay,
happened. We are working in a lot of new stuff, and I think there is gonna happen a lot during 2026. So we are gonna talk about that as
that's
well.
great. Yeah, it's great because I also want to know what's new. I haven't used Simumatic in the last month. I was
Yeah,
making some content, but it's great to know because I have some content in my mind that I want to create.
cool.
So maybe I
Yeah,
include these new
yeah.
features.
We are gonna talk about a little bit about code and compile as well, and so it's gonna
Cool.
be a lot of topics. I don't know how
Mhm.
long it will take. We will try to keep it short
Okay.
because it's gonna be a lot of talking and not that much playing around and hands-on like we
Okay.
usually do. But this is
Mhm.
just gonna be the first one, and
Okay.
probably most of the topics we are gonna cover will be topics for upcoming webinars during
Okay.
the year.
Okay. Okay.
So yeah, we have these three parts. We're gonna start talking about what has happened and what we have been working with. So actually, I
Okay.
wanted to bring the last four releases we have done.
Mhm.
As most of you probably know, we have announcement in the app every time we have a new release. I'm actually gonna share my screen,
Okay.
and I think if I go back to the start page, usually up here, yeah, we have
Okay.
the releases, what's going on, or what we have released each time. So I wanted to
Okay.
talk about all the last four releases.
Okay.
First one is this release 13, where we
Hmm.
improve a little bit the interaction modes.
Okay.
Actually, there is something that is ongoing that I didn't mention in the bullets for later, but the idea is to provide uh, three different interaction modes, both when
Okay.
you are editing the system or where you are
Hmm.
playing it. Yeah.
Okay.
So what does it mean? If I jump into the workspace again,
Hmm.
we all know that when you are in the workspace, you have the we could before select items and then
Right.
move them or
Right.
rotate them. Yeah.
Yeah.
So we had these three interaction modes, but we wanted to add the possibility that we didn't have before to even select items while we are
Okay.
simulating, because the default interaction mode while simulating was what we call the user action. So for
Okay.
example, when you click on a button, you see that it
Hmm.
goes inside.
That's a user action.
Yeah, yeah.
Okay.
Or when you click on the box, you can open it or close it. The
Okay.
problem was that sometimes you just, while simulating, you wanted to maybe check a connection or variable or something
Okay.
with one component, and you couldn't do that. You have to go to the
Hmm.
tree, left tree,
Right.
find the component, select it, and get that. So now
Okay.
you can switch between the user action mode and select mode, and
Hmm.
now you can select any component, and then here you have the connection.
Oh,
You can see the values and all this stuff. Okay,
interesting.
and as you see here, there is room for a third one, and the
Hmm.
idea with this third one is to introduce the feature we have had in VR mode,
Okay.
which is grabbing com- grabbing
Hmm.
products.
Okay.
So to
Okay.
allow the with the grabbing mode to click on one object and be able to move it or push it, so
Okay.
you can interact a little bit, maybe
Yeah.
switch positions, remove something
Hmm.
from the system, so you can uh, maybe kind of force some false
Okay.
situation, error, whatever. No.
And it's only for the components that are moving. It's not, you
No,
can't move the conveyor
yeah,
like this.
actually,
Right.
no, because it's gonna be using the physics. So
Yeah.
of course you will be probably you will be able to select and try to grab something, but
Hmm.
static elements won't be able to move.
Yeah.
In the
Okay.
other hand, if you have a robotic arm, you will be able
Hmm.
to grab one of the axes and try to force the position,
Cool.
but you will be able,
Okay.
but you will be like fighting with the controller because the controller is
Right.
probably trying to set one angle in each of the
Got it.
axes, and it's gonna be kind of
Okay. Okay.
confusing. But yeah, so that's one of the features that we add.
Mhm.
If we go back to the presentation, so the next one was that we removed the individual subscriptions, and this was kind of a strategic decision from virtualware. We want to
Right.
focus in educational organizations or industrial companies, engineering companies, and so on.
Mhm.
But we have a solution for those individuals that still want to learn more about automation. They are interested in virtual commissioning. They want to learn robotics, PLC programming, or whatever. And what we have done is that we are open to partnerships, for example,
Okay.
with Code and Compile, as we have with Code and Compile. So
Right.
we have partners that can offer these individuals a possibility to get access to Simumatik through their
Okay.
organization and their content
Okay.
and so on. So
Okay.
I think you have had several people that we
Yeah, I
kind of
think I have
sent to
about
you.
20,
Yeah.
25 people who are individually subscribed. And if somebody wants to know more about that, you can go to my website and you can find the way to buy directly on the website, individual subscription.
So
And I also have 2 courses which are given for free. Yeah.
So I think it's a pretty good option. It simplifies a lot because for us the individual
That's right.
subscription was kind of a pain as well to handle
Yeah.
all these individual payments and so on. But now through partners like Code and Compile, so we can canalize all these people that wants to work with Simumatik in a kind of hobby basis or learning students and so on. So we really hesitate to contact Code and Compile. Probably in the caption of the videos in YouTube or even LinkedIn, we can mention the link to your website so people can read about that. So that was kind of sad, but at the same time, I think it's a positive switch and brings other possibilities. Yeah. Then it brings us to the release 1.15, where we introduce the built-in gateway, and this is maybe a bit more difficult to explain, but the built-in the built-in gateway is kind of a solution we have offered to these customers, mainly in industrial customers, that require a boost in latency between the workspace and PLCs or robot controllers. Normally, we have, all the users know, we have the workspace where you execute the model, and then you can start the gateway, and the gateway will kind of bridge your controllers and the workspace, exchange signals, variables, whatever. There was a communication between, or there is still the communication between the gateway and the workspace, and then the gateway and different controllers, soft or hardware controllers. And this kind of increases a little bit the latency. We were having some customers that wanted to get under 5 milliseconds latency between the model and the controllers. So what we did is add the code of the gateway as well inside the workspace. Basically, it's the same drivers, everything is the same. It's just that it's built in the workspace, which limits a little bit the logistics, because this means that you will have the workspace and the gateway in the built-in mode running in the same computer, which sometimes having them separately could help because of the license, because maybe you had one license of one controller in one computer, you could install the gateway there because it wasn't accessible through the network or whatever, and then the workspace in another computer. Now you get some limitations because both gateway and workspace will run in the same machine.
Okay.
But at the same time you reduce the latency. So how does this work? It's very simple. As default, you will have the normal setup. As we all know, the gateway can be started from here. This button will connect to contact the launcher. The launcher, as everyone knows, will have the latest gateway download, and it gets connected. And then once it is started, you can just connect and disconnect very easily. But if you want to use the built-in gateway, you can go to the settings, and here you can click on this button. Sorry, and now I need to move myself from the screen.
You can hide us for a second.
I'm gonna hide us a little bit. Yeah. So here in the settings, and actually I don't see the. I don't know why I don't see my.
Make it full screen or something.
Yeah, I think it's full screen for some reason. I don't see, but it's this one. So use internal gateway. There is a checkbox. So probably now we can see it. Yeah, this checkbox.
Yeah.
So if we activate that checkbox, then this button is disabled, and now automatically, when we click on play, it will start the gateway. Okay, so that's kind of a difference. Before we could run the model without the gateway being active, but when you use the built-in gateway, then it's gonna start as soon as you click play. So it's kind of simplifies things as well. So in many cases, maybe you want to have it as default using the internal gateway, and actually when you activate this feature and you save the system, it's gonna be saved as part of the system preferences. So next time you open that system, it's gonna be this checkbox is gonna be checked, and you will have just the internal gateway selected. Yeah.
So what do you recommend? In which situation one should use internal gateway, and in which situation one should use external gateway?
Yeah. Usually for most of the users, probably using the external is enough and gives you more control about when the gateway is started and it's not started. You will have better performance probably because you don't need the gateway always running while you are editing and so on. You can also split a little bit the execution on the use of your computer cores and so on. But when in industrial applications, I think we get better results in average using the internal gateway. Because the latency, the latency becomes important, and usually our customers have more powerful computers. Usually the percentage of CPU used by Simumatik, both the workspace and the gateway, is just a fraction compared to tools like TIA Portal or Robot Studio or all these programming softwares, because those have become very heavy, and usually the model is not a big deal. But I will say give it a try and see if you can get improvements in the latency. I mean, it's just when you are talking about these last milliseconds, which may be very important in some industrial applications when you are moving axes and you need to have very high precision. Usually in education, when people is using OPC UA for communicating, it's not going to make a difference because you already are at 30-50 milliseconds latencies. I mean, it's not going to make a difference using the internal or not internal. This is more using S7 protocol for Siemens or the ATS protocol for TwinCat or Beckhoff. So it's these native protocols that can get a boost. Yeah.
Okay.
So that was it was a kind of big deal for some of the customers, and that was the release 15 last year. And the last one, which been around Christmas, is the catalogs. And maybe we can spend some more time in this in this topic, because I think this may open possibilities for some of our customers, but even more customers, partners, to become part of the Simumatik ecosystem. You know that from the beginning we wanted to make something that is not just a platform, that's why it's cloud-based and so on. It's not just a software to create digital twins or emulation models. We wanted to be able to share content, to create a community, and the catalogs could be something that can help to create this ecosystem. Basically, if we just mention, as I say, that you can publish content in Simumatik. People has been able to do that since the beginning. Basically, when you create a component or a system, you can go to the component or system editor and select that you want to share it, and then this will create a instant copy of that component or system and share it with anyone that has access to Simumatik.
Okay.
And that was a nice way to share content and so on. And we can see that there is some content. If I share my screen, when you go to load here, you can see the public components or systems in this case, and you see that there are several from some of our customers or even us that have published content. And this is the way, for example, we had used to share content related to tutorials in the academy and so on. So every customer or user has its own private systems and components, but there is this way to share publicly systems and components. But this public publishing mechanism, it was kind of too open for many people we were discussing, because maybe you want to try to monetize or see or just share some content with some specific users or organizations. And I believe that is a really good idea. It's done as, for example, by Unity. They have this marketplace there where you can buy plugins, contents, and so on. And the catalogs are kind of similar mechanisms. Basically, what we are offering now is that when you publish some content, you can decide to publish it within a catalog that your organization owns, and then you can decide who has access to this catalog. So far, this is done through communication with us, so we can activate new catalogs to our existing customers, and then they can tell us, I want you to give access to my catalog to this organization and so on. And this is because we just started. We just want to see the interest behind this mechanism, how many customers and partners are interested in that, because the idea is to build, as we will mention later, a marketplace where all this could be automatized somehow, both to create catalogs, but even to share the catalogs to whoever you want, or maybe people just purchasing directly catalogs for free or for money, and all this being somehow automatized or handled by a marketplace. So the difference now is that we can see these catalogs option. Right now, I think I'm in an organization that doesn't have access to catalogs, and that's why we cannot see anything. But let me see if I I go out and check. Let me see. I think we have some catalogs created by ourselves here. Probably we could
So the
have
catalog has systems and components both.
exactly. Actually, you cannot publish. It's like when you did publish a system, you need to make sure that all the components in that system are published.
That's right.
Because otherwise someone will try to open that system and
Yeah.
won't have access to components. So basically with the catalogs is the same. In order to be able to publish a system within a catalog, you need to make sure that all the components inside are already published in that or included in that catalog. So let's see. I think yeah, here we have some catalogs that have been created, and some you can see how in this case we have access to this catalog, so we can see that. How this is gonna be handled and how the users will see which catalogs they have access to and so on, I think is here. Yeah. So here in the administration page of each of the, I'm gonna hide us again. Let's see. Where is my mouse? Here. So let's see if I do like that. Now I think you see. So I need to do this. Now you see. So in the administration page, as before, we can see that this is our organization, but here you can see the active subscription key and all this stuff, and here you can see the catalogs that you own and which ones you are user. So in this case, we own this catalog, test catalog, and we have been given access to the catalog called test that is from another organization. And this is basically how it's gonna look like. So,
and how did you give the access? How did you add this?
You contact us. So far, you will need to contact us.
Okay, so right now it's in the backend. Okay.
So if an organization wants to start creating a catalog, because this is just the start of this new feature, we want them to contact us. We will support them how to introduce components in the catalog. It's pretty easy. I mean, it needs to be something that you can have a component and then you go to publish, and here you can select if you want to add the component to a catalog, and then you select your catalog and you can publish. So the process is pretty the same.
So I have one question. In an organization, let's say Code and Compile, I create a new system in the catalog. So is it automatically shared to my members in the organization?
Yeah.
Or do I have to also add them?
No. So when you have your own catalog, you will have all your organization will see the catalog. Okay. But you have the option, by default, because it's your content is published within the catalog, but everyone will see it. The big thing with your catalogs is that now all this work you have done to for your organization, you can actually sell it or provide it or give access to another organization. Yeah. And for doing that, you just need to contact us and say, okay, I want to give access to this organization. And then we just go and activate that, and they will get access. And it can be permanent access, or it can be limited access for a period of time. So that's not a problem. Yeah. So that's the idea. Is actually not very big feature regarding what you can do with the models and so on. It's basically a new feature that provides you a new way to share content. And that's
one more question. When I add this component and system in the catalog, can I also prevent that to be cloned?
Yeah. And that is what
I can control.
Yeah, that is like we did before when we published, like
block access.
And you can do that both with the system and component.
Got it.
Yeah. Actually, this actually blocks, so you cannot even see how the component is being done and so on. So it makes the components and system more like a black box.
Got it.
So you can, if in case you want to kind of safe or yeah, I would say your you want to make sure that your intellectual property or
Yeah, yeah, you know.
your creation is not duplicated or cloned. If
Right.
so
Or
you can,
sold further on.
yeah, yeah. So
Yeah,
you
got
could
it.
do that. Yeah, and it's
Okay.
anyway. It will all this content shared through the catalogs will go through the same process as we
Okay.
have for all the publishing content. So we actually check that
Okay.
the content is safe, is nothing that
Okay.
can harm someone or bad
Okay.
content and so on.
Mm-hmm.
So we
Mm-hmm.
look at the assets, we look at the component or
Okay.
system, and we make sure okay this is something that is okay to publish, even if it's
Okay.
not going to be published to everyone, but it's gonna be published to different organizations and will give access. Many people will get access, so we want to make sure that the content is good.
Okay.
So those were the things that we've been working and are out there. So it's been quite a lot of things going on.
Well, it's a very great feature.
Yeah.
And like you said, you're gonna make a marketplace. I think
Yeah.
this will
I mean,
make a lot of people interest to
yeah,
build something and they can sell it.
it will be great. So that's why this is kind of we will have we will keep talking about catalogs. We will do more posts in LinkedIn, and we are trying to attract partners and organizations to try the feature and see Simumatic as an ecosystem or platform where they can create
Mhm.
content and share it easily.
Mhm.
So it's also a way to become a partner somehow, because let's say you work in education, as in your case, and you identify some content that you could share with educational institutions in form of
Mhm.
courses, course material, models, exercises,
Right.
whatever. You can pack all that in catalogs, and then if you attract end users to Simumatic, you could become a partner, reseller partner
Yeah.
as well, and not just
Yeah.
monetize that catalog somehow, but also become a distributor of Simumatic and kind of get some commissions from
Right.
all these subscriptions. So this is something
Mhm.
that we believe that could empower a little bit the potential
Okay.
partners of distributors. Yeah, add additional value to just the Simumatic
Oh, that's right.
platform. Yeah. So next chapter, what's going on? and we didn't have a webinar for a long time, so it was a lot of things we had to tell, but there is a lot of things
Mhm.
going on. So it's already gone half an hour. I think I'm gonna try to keep it short because it's a
Okay.
lot of things. Okay. So what's going on? What is the team working on? Right now they are working pretty hard improving the 2D view or the drawings view in the workspace. So what was that?
Okay.
Let's see if I can open another system like before. I think I opened that and it had
Yeah.
some diagrams. So I
Mhm.
think most of the users will know that we can see the systems
Mhm.
in 3D, but we can also see
Mhm.
them in 2D. Okay, and
Right.
this is a feature that we added to somehow make connections or the process of connecting things easier, more
Mhm.
natural, but also
Mhm.
be able to have a more pedagogic view of the systems and components in education, because in many cases when you are building simpler systems you want the students to connect things or build their systems and understand diagrams and things like that. So we decided to go with 2D diagrams,
Mhm.
but the library for the 2D um, symbolic diagram tool wasn't giving us very good results. Actually, you know that we have this
Okay.
we have some features to create pivots and things like that.
Right.
Not super natural and efficient, and sometimes having a bit buggy. So the team has rewritten the entire code. We are using a new library now. It's not what you are seeing, so this is the old version.
Okay.
But they are about to deploy and start testing the new library. It's gonna be a thing of few weeks, I think. We will keep updated, and it's gonna be a new release. So basically,
that's right.
We hope we will give a new boost to this feature in Simumatik, and hopefully it's gonna be way more useful for the users that we know that there are many users that actually like that feature, but they saw it like a bit limited and buggy. So hopefully we solve all these issues, and it's gonna give it a boost. So that was one thing. I think the next thing I already mentioned is the catalog marketplace. Again, it's more an idea now, and we are gonna keep talking about that in the future. We just need now more customers or partners to be interested in that, in this feature. Start creating some catalogs, see how this feature works, see how people react, see which opportunities are opening, and when we see certain volume, we will go ahead and create this marketplace, so we make it easier, both creating catalogs and also getting the catalogs for the end users, and see how we can make also possible maybe monetizing these things.
Maybe we can also do, I'm not sure, because you have some credits. They can buy some catalog with credits.
Yeah. So
just to include.
Yeah. So we need to see how we can do that. But I think it's after talking about the catalogs, I think people understand what the catalog marketplace could look like. Yeah. And then is 3 big things. So we will be working this year. These 2 are quite advanced now. So the first one is the co-simulator, and this is something that we have kind of identified in some of our industrial customers, that sometimes it's not just about 3D physics and creating machines and so on. There is logic that is needed to emulate part of the system and kind of make the PLC or robot controller believe is controlling the real thing. And sometimes it's logic that is very difficult to emulate with physics engine and so on. Maybe we are talking about processes. We are talking about maybe frequency inverter logics that are I think we have had several webinars talking about frequency inverter and servo controllers and so on. What we have been doing many times is add kind of reverse engineering the servo controllers, adding the logic that is supposed to be inside the controller of the servo or frequency inverter inside Simumatik, and then all that logic just to make the PLC believe is controlling is talking to the real frequency inverter or servo controller, but at the end we just need to we just want to move an axis or something, or a conveyor in the model. So I guess that most of our users know about one of our competitors, Simit, which is kind of a 2D tool where you can add logic and connect it to a PLC. So basically this co-simulator is gonna be kind of this 2D tool. It's gonna be an interface, simple interface where you can add blocks and connect them to signals in the PLC or robot controller and so on in parallel to the workspace. That's why we call it the co-simulator. So you probably will have the workspace running with your model, 3D model of the machine or whatever you have, but you may want to move part of the logic that previously you were doing in Simumatik to the co-simulator to simplify things, because that logic is maybe not related to any part, mechanical part.
Is it like a separate application window which will be open, and there you can write the logic?
Exactly. And just because we want to make things open and transparent and so on, we decided to go with FMU or FME standard. So basically, for
Okay.
those that don't know about FMI, this is an standard that has been created several years ago to be
Okay.
able to package simulation models into black boxes that can be executed anywhere. And what is inside these FME or FMU blocks can be created in many existing tools right now. So for example, I was using a lot of MATLAB Simulink when I was in the university, and this is with Simulink you can create all these 2D block diagrams, so on. There is a way to export a model done in MATLAB Simulink to an FMI or FME block, and then we can execute it in our co-simulator tool. So the idea is to base the co-simulator in a standard that nowadays, if we check which tools, I mean, it's a huge list of existing tools that actually are compatible with FME. So the idea is that allow our users to create their own FME blocks using Python scripts, or if they have created, or someone in their team have created a model that represents part of the process they are trying to control, they could just drag and drop it in our tool, and together with other logic they have created, or maybe other models created from other tools, execute all together in parallel with the workspace, connected to the PLC specific or robot signals and so on. So this tool will have as well, we'll have this kind of 2D diagram aspect where you can connect things, blocks to each other and so on. As I was mentioned, the blocks can come from any tool that is compatible and is gonna be able to import them and execute them. So we kind of open a little bit the options here, and then we will introduce the gateway to this tool as well. So all these drivers we actually have in the workspace to connect signals to in the workspace to different PLCs, robots, and whatever. All those drivers will be also available in this co-simulator.
So in a way, before actually working on the PLC and robot programming, I can test my system using this, which will be faster. Before setting up the TIA portal or codices, this will be the first step, would you say?
No, actually, part of the idea is that part of the model, instead of being in the workspace, could be here, just in form of just plain logic. But in the main, as the main use case, you will connect signals to the PLC or robot controller as you were doing before with the workspace. But your question is interesting because we also want the co-simulator tool and the workspace to be able to connect to each other, and that could bring us to the use case you are mentioning, maybe controlling the model from the co-simulator. So connecting, adding logic in the co-simulator and connecting the outputs in the co-simulator to the model and the inputs from the model to the co-simulator. So you could actually do what you are saying, write pseudo code for the PLC in the co-simulator and run the model. But in the use case we have seen, and kind of what we are looking for, doing the same kind of thing that you can do with CMIT, for example, is providing the possibility to have code, very simple code, or maybe even more advanced code, but encapsulated in these boxes, these FMUs, that are running in parallel to the workspace, just to simplify some things. So that is gonna be something that probably, if it's not in April, in May, probably we will have a webinar about that and maybe show more about the progress and how it looks like and so on. So we are very excited because it's something that ourselves and some of our customers are looking forward to start using.
That's very interesting because I remember when you showed the other screen, there was a software Scilab. That's what I did.
Yeah.
I used in my master's
Yeah.
for doing some testing, creating some PID responses.
Exactly, and the thing is that this FMI standard has become so big that most of the 2D simulation tools have integrated, and now you can export logic from almost any tool into these blocks that we will be able to execute, and the other way. So we will allow users to create FMEs or FMUs in our tool, and you will be able to export them to another tool. That's the good thing with this standard. It's kind of makes things easy. So it's not a lot of time left, so I'm gonna take it quickly now. Local viewer with VR. This is something that a lot of people ask as well, and we really now when we are part of virtualware and we really love Baidu and all the possibilities with multi-user VR and multi-location and so on, we really want our users to start taking the step to use VR. We have been working a lot to improve the performance when using VR to grab stuff and navigate and so on. And we decided to give a little candy to all our users. So before they jump into the multi-user, multi-location solution of Vero and buy license and so on, or create a Vero room and all this stuff, we want to allow them to start playing a little bit with at least single user VR. Okay. And at the same time, we have seen that in many cases, the people working or using the models is not the same people as building the models, both in education and in industry. You can have simulation engineers building models, and then the end user in a company, in a manufacturer or industrial company, is the PLC programmer. And this PLC programmer basically just needs to open the model, click play, and debug the PLC or robot code. Okay. And the same in education. Maybe you have the teacher creating these models or exercises or virtual labs, whatever you want to call them. And then you have the students that they only want to open the model, click play, and play programming PLC. So for all those, basically what we want to offer is that we are testing now how to include what we call the local viewer, but it's just another way to enter the workspace instead of the web app. So you can just jump in without needing to log in or another license or whatever. You just enter the app, and once you enter the app, you can select which organization you will be working with. You select you start the local workspace, and then you select, I want to use the web app for editing and creating systems, or I just want to open the local viewer and run a system that already is prepared. And it's gonna look like what we had before with I think I'm gonna share the screen. I'm gonna show this video where I think we were showing Simumatik and PLC and so on, and then suddenly you open this viewer, the Vero app, and you could see everything render with Unity and so on. You see the rendering is nicer, performance is probably better because it's using OpenGL instead of WebGL and so on, but not many options here. So what we are working now is just a version of this app that is gonna be our what we call the local viewer that can be launched directly from the web app, and it's gonna have just a few features to allow the user to open a system, close the system, and just play and pause and reset. So you could be able to just play around with your PLC code and so on, but you don't need to use the powerful web editor with a lot of features, and you will be able to use this local installed Unity-based application instead.
And if I need to change the parameter, let's say IP address of the PLC or the IOs, then I need to go to the edit mode?
Yes, that's the thing. So let's see. We will start with just very few features because we don't want to complicate this local viewer thing. The goal is to have a place where you can use your keyboard and mouse, like in this example, to navigate and test your system. Also, be able to select if you want to go in VR mode and interact and so on. So we will have those options, but adding the right panel where you can change parameters and so on is gonna be like maybe too much, and we want to first see how people is starting to use this local viewer, and if actually we need to introduce more features or so on. We don't want to have two editors. So so that is the local viewer, and is under testing now. So hopefully in some weeks as well we can present it.
And one more question: this local viewer users can also use without VR devices, right?
Yes,
you have
both options.
Feature to use without.
So once you select that you want to go to local viewer, you will be able to select if you want to use keyboard, mouse, or VR. It's gonna be just one user per at the same time with VR or key and mouse, but at least it will give the possibility to experience the systems that you are creating with VR interaction and all this stuff.
Right. Okay.
And just last one, but not less important, is about physics engines. Okay, so for those that do not follow technically that much what Simumatik is using, we've been using bullet physics for many years, and it's been giving us pretty good results. But we have seen that when the computers are more powerful and we want to build very advanced models and so on, is getting to the limits where of stability and so on, when we want to create models with very high fidelity and a lot of degrees of freedom and so on. So we are looking to we have been working the past year, 1 year, rebuilding the workspace, so we can actually now have one or several physics engines that the user can select. It's just that now we need to implement those physics engines so we can start to see the differences and so on. But the big work of abstracting the workspace of the physics engine, it has been done. So now it's just we are doing tests with different physics engine and see the performance and good and bad things and so on, and if all cover all the features we need for Simumatik. And within the physics engines that we are looking at, of course, we have Newton from NVIDIA. That is the physics engine used in Isaac Sim, and this is open source. They say that is built for industrial applications and having very good results in robotics. As you can see here in their website, it's used for machine learning and different AI applications as well. And they have most of the, if not all, I think they have most of the features so far we have seen, like simulating conveyors and different kind of joints and different kind of shapes that we use and so on. So probably this is gonna be the first one we implement, but you see robots and so on, and it seems like it's gonna give us more accurate results. It's a more modern physics engine and pretty interesting.
But does it also mean that the user has to have a higher-end computer when we switch to this?
Not really. No.
The
opposite. It can be the opposite. That things that we were doing with the bullet fixes now are better implementing, and the performance can even be better. So
Mhm.
there are other kind of joints that we are very interested in as well, and very promising actually. So this
That
is
looks very
one,
interesting.
yeah. Then we have an eye in this physics engine. Maybe not that promising
Oh,
because Jolt is coming from video games. It's also
interesting.
open source. Performance seems to be really, really good. What we are concerned about is mainly accuracy. So we will probably need to do more tests, but what we can have confirmed is that they have, or this physics engine, Joule Physics, it has all the features we need.
Mhm.
So all kind of shapes, all kind of joints, simulating conveyors, different kind of
Okay.
axes, motors.
Mm. So
All
user
sort
can
of
select which physics engine he wants to
yeah.
work with, right? In the beginning.
The idea
Okay.
is that everything has been tuned to use bullets. So probably
Okay.
if you select another physics, you probably need to tune masses or frictions or whatever.
Ah.
It may happen because the implementation is different. So it may happen that just switching engines
Mhm.
won't give you the same results, and you may need to
Okay.
tune components. But probably if we actually end up implementing a new engine and the results are better, probably we will end up providing that as a default engine, so people when they create the new components they already are testing them against the new engine.
Okay.
But it's which engine you are using is going to be part of the system settings. So if you already have created a system, it's going to be saved as default to run with Bullet.
Got it.
If you want later to create a clone and start testing, making changes to tune it to another physics engine, then it's not going to be a problem. You can have both versions living together. Yeah. And the last one, this is a team in China that I met in Hanover Mess last year. Really nice team. They come from video games, and they had a video game physics engine, but they are developing, not finished yet, but they are working on this ModFIS Matrix Sim, yeah, simulation engine. Here we can see SACSIM, which is based on Newton. They tell their performance is better. We need to text, but so you see here as well, Newton failing here to keep it in balance. I don't know. You need to test these things by yourself.
Right.
What I can tell that I was really impressed with their stand when I met them in Hanover Mess, and we've been keeping an eye on them. Really good performance, and they seem to be. We are waiting to see if they can actually open source. They were going to open source the engine, and we are seeing if they actually end up doing it to see if we can implement it or provide it in Simumatik. So that was the last point of the things that we are working on. Yeah, and I like physics engine a lot, and I think it's super interesting to be able to work in those kind of things. So just to finish, and maybe just because we already are late and so on, I'm just gonna throw some questions here, and maybe we can have a webinar about that. But I'm super interested in AI. A lot of things happening. I mean, in 6 months since the last time we met.
Right, a lot.
This is going so fast. This is going so fast. We don't know where we are going, when AEI is coming, and what's gonna change in our lives, in our way to work, and so on. So we are having an eye on AI, and we are trying to figure out how we could use AI in Simumatik or with Simumatik. And these are 3 topics that we are interested in. And I'm just going to mention them shortly, describe what we believe. And it's going to be kind of an open question or open, I don't know, discussion. So if people watching this webinar is interested, you can comment on the video and so on, and maybe we can have a specific webinar. We probably will have a specific webinar on AI in the future, but we can keep a discussion, and you can tell us if you are interested in that. And these are the 3 topics that I believe gonna change a lot: emulation, digital twins, and so on. So first thing, of course, we are seeing that these LLM models, they help us with almost everything. They can translate, they can summarize documents, they have started to learn different languages, they can help us program PLCs, program software, websites, whatever. So why not train an LLM and teach that how Simumatik works, how you can build components and integrate that as a agent or whatever in the component editor and support our customers, our users, to create their components. I believe that's not very far. Our colleagues in Biro, they have been actually playing around with that, and they have an agent that helps creating Biro applications. So we are very close and looking at how we could do the same thing with Biro, mainly the component editor, because I believe is where most people spend most time.
It should not be difficult, because if you see, we have XML file for the component feel and look, and then we have the script which is written in Python.
Everything
if we train these 2 platforms, super transparent.
We have the XML schemas that super easy for LLM to learn and so on. So it's not far away, but I believe it could be something and helpful. We just need to test a little bit.
Right.
Then there is another thing, and we actually were checking these physics engines, and we are seeing that a lot of use of this open source physics engine is to test AI-based applications, like all these humanoids, these quadrupeds, robots. All this equipment is using a lot of AI, and they are training them, and they need virtual environments for safety reasons, of course, to test this. And at certain point, and quite close, we will see that many industrial applications will combine human program systems like PLCs, robots, maybe even half AI program PLCs and robots with this kind of AI control humanoids, quadrupeds, or whatever. And you probably want to test all these together. And we are looking at which ways we could have to create components. For example, this quadruped, create a component that is this kind of quadruped and connect it to the controller. So in Simumatik, we can reproduce what this robot could do in different scenarios and so on, in combination with the PLC robots, industrial robots, and whatever you have. So I don't see that far in the future that instead of operators, we will have this kind of mobile robots going around, picking up stuff and working mainly in logistics, but probably later in mounting operations and assembly operation and things like that. And all that need to be synchronized. There will be signals going both ways and so on. And you will want to test all this together. And
I think yesterday I saw a video. This company Xiaomi, they have humanoid robots in the factory plant. Instead of operators, there were humanoid robots doing pick and place and working with other robots in the conveyor line.
And this brings us to the third part: is safety and validating and verification and validation of all these applications, because there are a lot of policies in these robots, and I guess many companies are a bit aware of introducing this technology without testing that is completely safe in all different scenarios. And this is something that I believe is very important. I mean, you should be able to safely work in these kind of factories, even if there are a lot of humanoid operators, and even fall in front of one of these robots and be able to ensure that they are not gonna kick your ass or something, and it's gonna be safe. So
Right.
being able to automate testing of systems where more or less we have AI components, which means that we are not very sure how they will react in different situations. I think it requires more automated testing tools, and this is something that we are looking as well in form of projects with in research and so on, how we can build something on top of the Workspace and Simumatik platform, so we can allow our users to automate some kind of tests. We actually have some customers that using the API or the SDK we have for the Workspace, they can launch in the middle of the night, they can launch a Workspace, they can all start PLC program, and they can run sort of test. And when in the morning, then when they come to the office, they can see what has happened with the machine and so on. And I believe these kind of things will be more and more important as soon as we introduce more AI, and we want to make it easier to the end customer to use. So just wanted to throw that. We are out of time now, and I hope it was interesting. It was really fun to have this.
So many updates. I'm wondering how much work the developer teams are doing in the back end to bring all these apps together.
They work
so kudos to them.
They are.
I get
they work really hard. So I'm very happy with the developer team, and
no, that's very good.
We will see a lot.
Maybe you can shortly. You can shortly check if there is any questions in the chat. I'm also doing that. Otherwise, we can call it off. No.
Good.
So everything's okay?
Yeah, but then I think
if you want. When do you plan to deploy new scene system in Simumatik? Somebody's asking.
New what? The
new scene system in Simumatik. Maybe some new systems. Maybe someone is wondering if we have some new system for our public system.
Yeah. This is why we are trying to push this catalog. So we want
this catalog, right?
Yeah, we want others to be able to publish things and share and so on. So this is the way we want to open the community to be part of sharing and adding more systems. Yeah.
Right. I mean, maybe in the next webinar, if we are showing some new updates, we can also show some new systems if we have created in the catalog. We can also show that. And one more thing, if people are wondering how to build the system, we have an academy where you can learn how to build a component and how to build the system. So that knowledge you can use to build catalogs in the end. So if you have an organization or if you plan to buy an organization, there are resources to learn how to build a catalog.
Exactly, yeah.
Right.
Cool.
Yeah.
And, then, I think we call it for today. And
thank you.
See you next time. I think we won't have we won't have webinars every month now, but maybe every second month and so on. So depending how many ideas we have for the webinars, but we will really keep with the webinars.
Right.
I think it's very fun and useful. So see you the next time. Thank you to everyone watching. Thank you to the Simumatik team.
Thank you, everybody. Yeah. Thank you, Michael. Thank you, everybody, for the support. And I hope to see you next time very soon.
Bye-bye. Have a nice day.
Okay. Bye.